sure you've got a red pen in your hand to check off your work to make sure you got it right. You should have red pens in your supply boxes. If you have your own, even better. All right. So just to check in with each of you, okay? Discrete is going to be thumbs down, down, discrete, down for discrete, okay? Continuous is going to be thumbs up, and neither is going to be thumbs in the middle. You guys make sense? Yeah. Okay. And it was odds, right? Yeah. Yes. Okay, number one, what do we think for number one? Continuous, neither, or discrete? Good, I got all thumbs in the middle. This is neither. It's not completely continuous, right? There's a little bit of a break in between -2 and -3. So that would be neither. Show me on your thumbs, what do you think about number 3? Continuous, neither, discrete. Good, this is discrete. It's just a bunch of points, right? There's no continuous flow between them.
You said discrete.
Discrete, yep. Number 5, continuous, neither, or discrete. Good, this is absolutely continuous. There is one line connecting all the points we see. That's what it means to be continuous, right? And finally, what about number 7? What do we think about number 7? Continuous, discrete, neither. Okay, I see a whole bunch of different stuff. Yes, okay, we're looking at number 7, right? Are any of those dots connected?
No.
No. So that would be discrete, right? Now, if for some reason, I'm not going to draw on the book, but if I had one line going right here, that would be neither, right? Because there's part of it that's continuous, but it's not the whole thing. Super easy to tell just by looking. That shouldn't be too bad. If we go, perfect. We're going to worry about that later. Nope, don't worry about it. We don't have time. Okay. Number 9, Kylie records the number of hours she works in her after-school job each week, graphs the function, models the situation, use the graph to determine if it is discrete, continuous, or neither. It's a long-winded way of saying it's exactly like numbers 1 through 7. What do we think for number 9? Absolutely, definitely going to be discrete, right? Each dot represents a day, right? So we're not going to connect those days. It's did you guys learn scatter plots last year or no?
No.
Perfect. We're going to learn them this year. It'll be easy. It was basically just like that.
The dots are all scattered.
Correct. Kind of like we see here. Number 11. Blah, blah, blah. Is it discrete, continuous, or neither? What do you think? Thumbs up, down, sideways? Good. Adriana, I would agree. Raven, I would agree. Yep, Gurpreet, I would agree. This is discrete as well. Just a bunch of dots, nothing being connected, right? Not too crazy. This is where things get interesting, all right? With 13 through 19. Okay? 13 through 19. Give me a thumbs up real quick if you got non-linear for all 4 of those. I guarantee you if I look at your paper, you didn't work these out, did you? Let's take a look, because what did we do in the notes? We worked them out. We didn't just look for an exponent and assume something, right? That would be brash of us and incorrect of us. Let's look at number 1 not number 1, number 13. Okay, I've got x plus the quantity of root 2 times x squared plus y minus 2x squared equals 11. Now, I'm sure a lot of us looked at that and went, ooh, exponent, nonlinear, right? You don't have to put your thumb up out of embarrassment. I know that you did. Okay, it's okay. All right, root 2x squared. Alex, what is that equal to?
That is
2x squared. We distribute the exponent to both. The square root and the squared cancel, leaving me with 2. And x squared is just x squared. Okay, I've got x plus 2x squared plus y minus 2x squared equals 11. Is there any like terms I can combine here now?
Yes.
Yeah, Christian, what can I combine? 2x. Okay. 2x squared and negative 2x squared. What happens to those terms? They cancel out. Look at that. All we had to do is one little step. X plus y equals 11. Is that in my standard form?
Yes.
Yes, it is. So what type of relationship is this?
Linear.
Linear. Please make your changes now. I would honestly work this whole thing out on your paper if you selected or wrote non-linear. Okay, I didn't spend all that time in the notes working out all those problems for no reason, right? Some of them are trying to trick you. That's exactly what we talked about in the notes. Is there any other ones trying to trick you? No.
How do you do number 19?
That's the one 19.
Number 19, perfect. Thank you, Gurpreet. Number 19. Y equals negative x cubed plus 2x. All right? I'll leave that up just for a second. So when we're working this out, we want all of our variables on the left and one single constant on the right. Do you guys see a constant in there? No. Do you see a constant? I see a y, an x to the third, and an x. I don't see any constants, right?
Yeah.
So what I would do, right, is I could add x to the third and subtract 2x. Add x to the third, subtract 2x. I get x to the third minus 2x plus y equals 0. That's as close as we're going to get to writing this in standard form. Is this written in standard form? No, why not?
It has 4 letters.
It has 4 letters.
X third. This x third is A. Negative 2x is B. Y is C and 0 is D.
Good. I'm glad you brought that up. This is our standard form, right? Where A, B, and C represent what again? Numbers. Not letters. Numbers. Okay? Negative 2 is my A. 1 is my B. 0 is my C. Well, what the heck is going on with this thing?
It gotta go.
It's got to go. Can I do anything with it?
No.
No.
Can't do
So what type of relationship is this?
Non-linear.
Non-linear. That's when we know that our relationship is non-linear. If we've got our standard form, but there's a little dude hanging out that's not supposed to be there, right? Party's over, he hasn't gone home yet. That's what we're looking for, right? A little x to the third. That tells me when I graph this, this is not going to be a straight line. This is going to be some weird, funky, curvy line like that. That's how we would do number 19, okay? 15 and 17 are both non-linear too. If you just guessed that because you saw the exponent, you got lucky. You might not get that lucky on a test. Let's look at number 21. When we got a table like this, all we got to do is see if we have a constant change in x and a constant change in y. So if I look at my x values here, what am I changing from point to point to point? What am I adding each time?
You add 1 each
1,
time.
right? Plus 1, plus 1, plus 1, plus 1. Okay, how do I get from 3 to 5?
2.
Plus 2. How do I get from 5 to 11?
6.
Plus 6. Is that the same change in y?
No.
No.
It's non-linear.
So it's non-linear. It is not a constant change. 23, again, I see a constant change in my x's of 1. How do I get from 35 to 41?
6.
Plus 6. What about 41 to 47?
6.
To 53?
6.
To 59?
6.
Is it a constant change in y?
Yes.
Is it a constant change in x?
Yes.
Yes. What relationship is that? Linear. Okay. So I'm giving you guys a break. A lot of you just wrote linear or non-linear. I guess it doesn't say explain how you know, so you got me there. In the future, just a brief explanation. The change in y is not constant, right?
Oh, wait.
Any final questions on here? Perfect.